So welcome to our channel Electronics on Wheel. So many of you have requested me to make the video on electric vehicle, and here we came based on your request. So thank you for your support. Please like, subscribe and comment if you like the content of this video. So today we will discuss about the electric vehicle, and where we will discuss the different topics which are mentioned here. So if you want the content of this particular videos, you can visit our website electronicsonwheel.com. There you can get the this particular content in the form of article. So let's start with the content. So we will try to understand the basic of the ev electric vehicle. What is the ev? Then we will see what type of different type of electric vehicles present in the market. What is the then working principle of bev, then main component of hev, working principle of hev. Then we have PHEV, that is nothing but the plug-in hybrid. What is the difference between plug-in hybrid and HEV, hybrid electric vehicle? We will see what are those two modes on which it can run. Then what are the main component working principle of plug-in hybrid? Then there is a new term coming in market, that is FCEV, that is fuel cell based EV, and where we are using the hydrogen. So we will see that also, and working principle and some of the examples of fcev. So this is the basic things we will cover about the ev. First the basic content, then we will take one particular deep down deep session of electric vehicle. So we will see what are the key component of all electric car, all electric or ev. What is the secondary battery, what is the use of secondary battery in the electric vehicle, whether we have or not. Then we will see the what is the charge port, then what is the function of dc converter. Then we will see the traction motor, onboard charger, then power electronics controller or inverter. Many of people confused about the power electronics controller or inverter, whether it is same or is there any difference. Then we will try to understand the difference between these two terminology. Then what is the traction battery pack, then transmission. So these are the topics which we are going to cover in this video. So let's start with the first different type of ev. So there are mainly three types of ev, that is electric vehicle. One is battery electric vehicle, which you already know, that is fully powered by electricity and nothing but the battery pack. So this is what it is written here, that these are more efficient compared to hybrid or plug-in vehicle. The 100% power is taken from the battery to run your vehicle. Then hybrid electric vehicle, as its name suggests, hybrid, it means that these vehicles are run by the ICE engine and the motor as well. So we will see what type of HEV we have. So HEV nothing but hybrid electric vehicle. So basically they use both internal combustion engine, usually petrol engine or diesel also can be there, then battery powered powertrain. So there would be a motor also which is going to assist the engine during the movement. So this is the difference between hybrid and electric vehicle. So in electric vehicle you do not have ice, that engine, combustion engine you do not have. You have totally motor, only one motor or two motor depending on the which car you are having, or rear wheel or front wheel so there are different terminology for that, whether you are using two motors or one motors. But there will be only motor for BEV. But in hybrid case, you will be having the combustion engine and battery and motor as well. So petrol engine is used both to drive, charge when battery is empty. So when you have the battery to run your motor, then battery will be charged through the petrol engine, the combustion engine on which your vehicle is running. This vehicle not efficient as fully electric or plug-in hybrid. So what are the some example of hybrid vehicles? First one is 12 volt architecture and 40 volt architecture. So I have created one video where I have explained clearly what is the 48 volt architecture and 12 volt architecture. I will comment the video link in the comment box or the description. So there you can check out those videos. Clearly I have defined that what is the meaning of the 12 volt architecture and 48 volt architecture. If I say in brief, so it means that you will be having the motor which is giving some power to your vehicle, and it depends on the voltage, on which voltage it is working. So you will be having 12-volt architecture and 48-volt architecture. I will show you that when you are using 12-volt architecture, then how much kilowatt of motor you are going to use, and when you are using the 48-volt architecture, then how much kilowatt of volt motor you are going to use. So one is hybrid vehicle, then other one is plug-in hybrid. Plug-in hybrid uses both internal combustion engine and battery charge from the external socket. So sorry, if you see in this case, hybrid, in HEV case, you will be having ICE engine plus motor plus battery, and battery is dedicated to run the motor. When you have the PHEV, you will be having same thing, ICE, then ICE nothing but it is internal combustion engine, motor plus battery. But in HEV, this battery is charged from the ICE, your engine. But when it comes to PHEV, your battery will be charged through the ICE, plus externally you can charge this battery to run your motor. So this is the advantage in PHEV. Sorry. So this is the advantage in PHEV plug-in hybrid vehicles, that you can charge your battery from the outside, from the external source. This means that vehicle battery can be charged with electricity rather than the engine. PHEV are more efficient than HEV, of course, because you are charging your battery externally, and the battery is also is a big battery, and motor power is also bigger than compared to HEV. So this is the difference between HEV and PHEV. We will see further how they are different in architecture wise. Then you have the fuel cell electric vehicle. So this electric energy is produced from the chemical energy. So where you have the example of hydrogen FCEV, fuel cell electric vehicle. So we will see the for architecture of HEV, the electric vehicle. So where we will see that how much kilowatt of motor is used for which type of vehicle. So let me clear it, erase it. So here I will show you little bit more. Okay. So as I explained you earlier, so HEV, if you see, this is the architecture where you have your gasoline engine in the front, and your electric motor here, and your gas or your petrol would be, gasoline would be on the rear side. Then you will be having the PHEV, that is plug-in hybrid vehicle, where you have the gasoline engine, electric motor, and battery also. But battery power would be more because you have the option to charge your battery from external. This is the advantage in PHEV. But as you can have the bigger battery, then your cost will be also high. We will see all these parameters in the coming slides. So you can charge your battery from the grid and ICE engine as well. So you have both option, but here you do not have the option of charging your vehicle from the external source you have here. Then BEV is completely, you have the battery only and electric motor. You do not have any ICE or gasoline engine, and of course you have to charge your battery from the external source. So this is the gist of this particular slide. So moving further, system architecture, there are four type of electrical architecture. here I have given the motor power, and this is the vehicle segment A, B, C, D, E, F. This is nothing but the defined by the NEDC. Okay, this is the agency in the Europe which measure the emission, which defines the emission norms. So if you are using 12-volt micro hybrid, so this is all coming under the HEV. This is coming under all HEV. This is your PHEV, and this is your BEV. So here, if you see 12-volt micro architecture, so here you will have the motor, but motor power would be less than 5 kilowatt, and voltage stabilization system only you have to use. Other than this, you have no need to use any additional component. So where you will use the 12-volt micro architecture, then you will be saving only 3 to 4% of CO2. Then if you have 48-volt mild hybrid, then you are using 5 to 15 kilowatt of e motor power, then 13% you are saving on the CO2. But when you are going to 48-volt architecture, then you have to have the DC DC converter. Why you should have the DC DC converter? Because most of your accessory will be working on the 12-volt, so you have to convert your 48-volt to 12-volt. We will see further there is a method to convert, and there are some accessories which can work on 48-volt architecture also, and some of the accessory will work on the 12-volt architecture. I have written one article on 48-volt architecture which is Tesla is following. You can check out that article and how they are going. In 48-volt architecture, we will be having, that is BSG, that is called belt start generator, and ISG, that is integrated starter generator. So what happens here, your motor will work as a generator, motor will work as a generator, and generator will work on a motor. So you just comment in the description, comment in the comment section, that when your motor will work as a generator and your generator will work as a motor, there is a condition. So this is the condition for the 48-volt mild hybrid. Then when you go to the above than 48-volt, so if you see the low voltage circuit, our low voltage circuit and high voltage system. Okay, low voltage system and high voltage system, our system is defined like this. Low voltage system comes from till 60, till 60 volt. High voltage system above 60 volt. So when you are going to the full hybrid, then you are using 20 to 40 kilowatt of e motor, and you are going above the 60 volt, where you have to use the some additional insulation, because you are going in high voltage. You have to give the additional insulation and other stuff. High voltage power electronics you have to use, high voltage axle drive you have to use. So when you are using all these stuff, then your car cost will be increased. So that's why you might have seen that if you are taking 48-volt mild hybrid or PHEV, then there is a lot of difference in the cost because of this only, because you have to give the high insulation, high safety measures you have to give, because you are going to the high voltage. When so this is about the full hybrid. Then PHEV is plug-in hybrid, where you use the motor capacity of 60 to 120 kilowatt, and you are saving around 50 to 75% of CO2. Then last comes the electric vehicle, that is 60 to 150 kilowatt, and it is using 100% CO2. But theoretically, because your electricity is also coming from somewhere, you are burning the coal. So but theoretically you are saving uh, indirectly. So this is the overall description of all the system architecture. You can check out this 48-volt belt starter generator video, where I have explained everything in detail. that why we cannot go beyond the 60 volt, and what are the reasons. If you are going beyond 60 volt, then um, the cost of the vehicle will increase. So moving further, we will start with the BEV. So BEV also known as all electric vehicles. So because you do not have anything, you have just battery pack and then electric motor. So entire BEV will be powered by the electric drivetrain, that would be electric motor. So sometimes you will be having two electric motor, one is on the front and one is on the rear, but sometimes you will be having only one electric motor which is on the either rear side or the front side. So all the energy will be stored in the battery pack, and you can charge your battery through the electric power grid. Charge battery pack then provides power to one or more electric motor, which I have already told you. So this is the architecture of your BEV. The main component of BEV is electric motor, then inverter. So here we have not shown the inverter. I will show you what is the function of the inverter, why we are using the inverter. Then battery, of course, that is battery pack. Then control module, we will see that control module, and then drivetrain. Drivetrain is nothing but that is the electric uh, transmission. So with this transmission also would be there, we will see that thing. So what is the working principle? So let's understand the working principle of BEV. So power for the electric motor is converted from the DC battery, this is your DC battery, to the AC. Why we are converting this DC to AC? Because we are using the AC motor. So most of the passenger vehicle are using the AC motors. However, there are few vehicles where we use the yeah, DC motor also, that is our BLDC motors, so brushless DC motors. So where you have the two wheelers and you use the DC motors as well. But in all the passenger cars, most of the passenger cars, you will be using the AC. So we are converting this DC battery to AC. Then when you are pressing the accelerator, a signal sent to controller. Controller adjusts the speed of the vehicle by changing the frequency of AC power from the inverter to motor. So basically the controller, it does, it changes the frequency, and based on the changing the frequency, it controls your motor. Then motor connects and lead to the turning the wheel through the that is your transmission. If brakes are pressed, then electric car is deaccelerating, and motor becomes an alternator and produces power which is sent back to the battery. So this is the overall working principle in a short, but we will see in in detailed way how, what is the port box, what is the contactor, how they are working, what is the battery pack, what is the module, what is the cell balancing. So we will explain you in detailed way in all throughout this video, or we will make the second video for this, so that it will not consume your more time, but we will explain in the deep what is the technology behind this. So moving to the HEV, that is hybrid electric vehicle. So in hybrid electric vehicle, so this can be a series hybrid or parallel hybrid. What does it mean? That you can use your motor in with engine in in series or the parallel as well. So you can see your fuel tank, then your engine, then you have the your electric motor, and the battery is powering your electric motor. So HEV are both engine and electric motor. The engine gets energy from the fuel, of course, and motor gets the electricity from the battery. Then transmission is rotated simultaneously by both engine and electric motor. In HEV, this is the concept. Then this drives the wheel. But when you go to the PHEV, so in PHEV, you can have the two modes. Either you can run your vehicle on engine, or you can run your vehicle on the completely on motor as well. But in case of HEV, your vehicle will be run simultaneously by engine and electric motor. This is also one difference between PHEV and HEV. So main component, engine, of course, electric motor, battery pack with controller and inverter, as I told you, that fuel tank and control module. So fuel tank supplies the energy to engine like a regular car. Battery runs on electric motor. Both engine and electric motor can turn the transmission at the same time. This is the difference between HEV. So coming to the PHEV, that is plug-in hybrid, so also known as a series hybrid. So they both engine and motor. They have both engine and motor as we have in HEV. You can choose among the fuels, conventional fuel such as petrol or alternative fuel as a biodiesel. You can it can also be powered by rechargeable battery pack. The battery is charged externally, so the concept is same, but here, as I told you, you can choose the two modes: all electric mode, where your motor and battery provide all the car's energy. So motor is also working, and your um, sorry, in all electric mode your motor is only working, and in hybrid mode, when both electricity and petrol diesel are employed, so you can run entirely uh, your car based on the electric motor, electric mode, or you can use the simultaneously mode also, like engine is also working or motor is also working. So this is the PHEV. Then main component of PHEV, that engine, of course, inverter, the same component which we have. So here we have the onboard charger also, because you are plugging out from the outsource. From external you are charging your battery, so OBC would be there, onboard charging. So PHEV is startup in all electric mode and makes your electricity until their battery pack is depleted. Once the battery gets drained, that engine takes over and vehicle operates on a conventional and non plug-in hybrid. So suppose you have run your vehicle on all electric mode and you are not using gasoline. So your vehicle will run till your battery is depleted. Once your battery is depleted, then gasoline will take up. Okay, that engine will take up and it will charge your battery also, and you can also plug your battery from the outside. PHEV can be charged by plugging into outside source, engine, and regenerative braking. So so PHEV, as I told you earlier also, PHEV can be charged by engine first, then external source, then your regenerative braking. Regenerative braking is nothing but when you are uh, applying the brake, then your motor will become as a alternator, and alternator charge back to your battery pack. So this is the regenerative braking. But it is not like you cannot do the regenerative braking in HEV also. So in HEV also you have the regenerative option, where you have the motor and your motor can become as a alternator which can charge your battery, and your vehicle can run on the battery. So when brakes are applied, the electric motor act as a generator using the energy to charge the battery, the same thing which we have seen. Then engine power is supplemented by electric motor. As a result, smaller engine can be used and increasing the car fuel efficiency without the compromising the performance. So this is the difference between PHEV and the HEV. I hope you understand. I have seen many videos on YouTube and I got that there are many people who said that when you are using the ICE engine, then you cannot have the regenerative braking. But it is wrong. If you are having the motor in your vehicle, either through the PHEV or either through your HEV, so you can use the regenerative braking when your motor can become your alternator or generator which can power your battery. Okay, so let's move to FCEV, that is fuel cell electric vehicle. So it is known as zero emission vehicle. They employ the fuel cell technology to generate the to run the vehicle. The chemical energy of fuel converted directly to electric energy. So you have the hydrogen tank, and hydrogen tank, you after hydrogen tank you will be having the fuel cell. This fuel cell will give the energy, and you will be having the battery will be charged, and PCU, that is nothing but the controller, and you will be uh, running your electric motor through this battery. So concept is same, but instead of taking the electricity from the charging station, you are using hydrogen tank, and you are making the chemical energy into the electrical energy. So here also you will be having electric motor, fuel cell stack, hydrogen storage tank, then battery converter and controller. These are the basic component which you will be having. FCEV generates the electricity required to run this vehicle on the vehicle itself. So you have the example of Toyota, Hyundai also, Honda also. These are the vehicles which are running on the hydrogen as well, but it is not successful as of now, because there are many constraints, as you have already problem for the charging stations for the electricity. Similarly, you have the problem for the hydrogen as well. So you cannot keep every petrol pump, you cannot keep the hydrogen. There are some constraints, there are different storage limitations. So this is into a evolving phase. It is not yet developed, and mostly OEMs are working on this technology for the CV commercial vehicles, uh, not for the passenger vehicles. So let's start our key component of electric cars. So key component of electric cars, if you see, so you have the first, we will start from the onboard charger. So this is your the onboard charger where you are charging your vehicle. Then once you charge your vehicle, then when it will go, then it will go to your, so let me start, 1 second, sorry. So this is your charging port. From the charging port, it will go to onboard charger. After going to onboard charge, it will go to your battery pack. Your battery pack will be charged. So after that, DC DC converter would be also there, and DC DC converter would be converting your energy to charge your auxiliary battery. That is your auxiliary battery, and this auxiliary battery is nothing but giving the power or electricity to vehicle accessories, many other functions which are working on the 12 volt. Then you have your electronic controller. So electronic controller or inverter is same, which is converting your DC to AC, and there are many other functions which power electronic controller or inverter does, and it is controlling the frequency also, to control the speed of motor also. So it comes, sometimes it comes as a separate, but sometimes it come as a single unit, controller plus motor, this. Then you have the thermal system cooling. So thermal system cooling is used for entire battery pack and many other uh, you know components. You do not have the similar AC provisions as you have the ICE engine. You have the different technology for the thermal ICE, uh, to for the AC and other stuff. Then you have the your traction battery pack. So we will start one by one. First is the battery, that is all electric auxiliary. So battery, we are talking about this battery first. So what is the function of this battery? This battery provides the electricity to the vehicle accessories. So vehicle accessory like headlamp, your horn, your other stuff. There are many accessories which you run, audio or cluster, infotainment, and many things. So this particular power is given from your auxiliary battery only. It cannot be directly connected to from this battery, that is traction battery. This is your main battery in electric vehicle. So first, this particular voltage will convert it from the DC DC converter to auxiliary battery, and then it will distribute it from auxiliary battery to other accessories. So this is the function of auxiliary battery. So starting with the charging port. So charging port, what exactly it does? So you can see this is the location in the MG so where you can charge your vehicle or your battery pack from the external. So there might be different position for the different OEMs, but this is the one of the position also. So what it does basically, it allows vehicle to connect the external power supplies in order to charge the battery traction part. So this is the first thing. What else it does? Charging port usually mounted where the original fuel filler is, so either in the back side or here also, but it it depends on the OEM where you are putting your onboard charger and other stuff, and how you are doing the packaging of your component. It all depends. It connects battery directly to the charging system within the car, which turns the charger charges the high electric battery, that is traction battery traction pack. Electric conversion in UK and Europe usually use the type 2 plug. We will see what type of plugs we have. Okay, there are different technology on the charging port also, so we will see in the in detail when we will go one by one. But as of now, you understand what are the components in the end, what is the function of that component. So most of the people did not realize you can change your electric car conversion using a normal 3-pin socket in UK. Although the slow, this allows you not to worry about the finding the charging station. So this is not a issue whether you have the two plug, 2-pin socket or two 3-pin socket. So it all convertible, and you have the different type of socket, and you can manage on that. That is not a problem. An electric car converts our battery pack can charge from 0 to 100% in around 8 hours on a normal plug-in, although this is just 4 hours if you are using a purpose wall mounted charging station. So this is your charging port. So I'll show you the different location based on the other different companies. So if you see, we have seen one position in the this image. Sorry, this image. So this is the front image. So this, you if you see, the Nissan Leaf is also using, Renault also using, MG ZS EV also, Honda E also using this front grill. MG ZS EV in 2020 they have used this location. Then Hyundai Kona is using this location. Then left side of your car, Jaguar I-Pace is using, Audi e-tron is using on the right side. Then BMW is using on the back side. Ben, uh, Mercedes EQ series, it is using in the back side. Mitsubishi also on the left, it is using Volvo. So it depends, all depends on the how your vehicles uh, component packaging is placed. Okay, so based on that, the charging port location can be changed. So this is what they have explained here, we have already covered. Now coming to the onboard charger. So once you have your charging charging port, after that it comes to onboard charger, your electricity. So it takes incoming AC electricity supplied via the charge port and convert it to the DC power for a charging the traction battery. So your battery is your DC, right? Your battery pack is DC, so it cannot charge by AC. So you will be having something which converts to DC power. So what is that component? That is an onboard charger. It also communicates with the charging equipment and monitors battery characteristics as such as voltage, current, temperature, state of charge while charging the pack. So this is a kind of onboard charger. It will look like this, and it will give it will take the input from the charge port as AC and provide the DC to the battery pack to charge your battery pack. So here also we can see in little more description. So you will be having the AC charging input from your charging port, then it will come to your onboard OBC onboard charger, then it will go to your battery pack your battery pack will be charged, then it will come to your motor or inverter. First it will come to inverter, electric motor. This is the one single piece with electric motor and inverter and electric motor is integrated. This is your battery pack with BMS. This is also the integrated part. It doesn't come with, like, BMS is coming separate and battery pack is separate. So it is all integrated. BMS is battery management system. We will describe each and every component in the coming slides. Then you have the DC DC converter. This is the position. So DC DC converter, as I already told you, that it converts your voltage to charge your battery, that is your low voltage battery or the secondary battery or the auxiliary battery, to power up the accessories. Then you have the wireless charging pad. That is, it depends. It is not necessary. So these are the flow of the EV. Now, third component after your uh, onboard charger, it's come as battery pack. So battery pack, as you all know, that it stores the electricity for the use of electric traction motor. So it is a very significant component, and most of the cost comes because of this component in your EV. It is the biggest and most expensive, and ultimately determines how much power and range vehicle will have. So how much is the rating for this particular battery pack, we will try to describe in the coming slides. But as of now, vehicles are using 800 volt, 400 volt, 230 volts. Okay, we will see who is using what and why they are using. So pack is made up of number of separate batteries. You can see these are the small battery which you are using in your uh, normal life, whether you are using in your toys and your watches. These are the battery packs, similar lithium ion batteries. They are linked together and carrying 5 to 25 battery in one, and which consists 100 of individual cells. So these are the individual cells. So like these 100 of individual cells you will be having, and 5 to 25 battery can make one module. Okay, we will see what is one module, what is one cell, then how it becomes battery pack. But to give you rough examples, around 7,000 cells in one battery pack are in packaged in one battery pack, around 7,000 cells. Then this is the same thing which we have explained already. So you will be having battery management, that is BMS, and which will monitors your voltage, temperature, current running through the pack when your charging and discharging is happening. And if it ensures that your battery is not damaged by excessive temperature or voltage. BMS links to the charging system and motor controller, constantly sending and receiving the signal to ensure the battery pack is operating uh, normally or optimally. Finally, battery box is a cooling system running through it, connected to external radiator and water pump. We will see that also. This cooling pump system runs coolant inside, that is glycol, in each battery within the pack to ensure that all battery are running at the same temperature and does not get too high. Okay, then transmission refers to mechanical power from the electric traction motor to drive. We will see this later. But this if you see this lining, this is the cooling mechanism which Tesla is using. And in these lines, uh, a coolant glycol runs, which cools the battery and maintain the temperature of your battery pack or battery individual cell as well. So it looks like this. So this is your BMS, which control your everything, now whether it is temperature, voltage or current, and many other factors. These are the contactors These are the two contactors. We will see how they are used, what is the use of the contactors. Then this is a pyrofuse. What is the use of pyrofuse, we will see in detail when we will discuss this particular one component in detail in coming slides. As of now, you just understand what are the components here. We have the port box also. Why port box are used, we will see. Then fourth component is inverter and control. So once we started from charge port, then OBC. So let me see here. We having charge port, then it goes to OBC. Then we have the battery pack. Then we goes to inverter or controller. And sometimes this is the integrated part of the motor. So what does it does, this particular unit? So this unit manages the flow of electric energy delivered by the traction battery, controlling the speed of traction motor and torque it produces. So basically this particular controller or inverter decide, or you can say the brain of your vehicle is this inverter and controller. So inverter is a device that converts first that DC power to AC power, uses for to run your electric motor. Then what it does, an inverter can change the speed at which your motor rotate by adjusting the frequency of your alternating current. It can also increase or decrease the power or torque of the motor by adjusting the amplitude of the signal. So you can see that inverter and controller is the main brain of your vehicle. Like in internal combustion engine, in internal combustion vehicles, you having the brain like ECU, that engine control module or ECM. But here inverter and controller is the brain of your vehicle, which is controlling many things. First, it is converting DC power to AC power to run your electric vehicle. Then what more it is doing, then it is rotating your motor by changing your frequency of alternating current. It can decrease or increase the power also by changing the signal amplitude. Inverter, which is also called a motor controller, converts the direct current from the battery to alternating current, which is subsequently delivered to the motor. Think of it as a link between battery and motor. Without it, would spin at full speed whole time. So if suppose you do not have this particular unit, then your motor will spin whole time at a higher high speed, whatever speed it has. The motor controller will be connected to the throttle of the vehicle as well as battery management system. So this motor controller will be connected to the throttle of the vehicle or accelerator pedal of the vehicle. I have shown you two contactors there. They plays very crucial role. We will explain one by one. And as well as battery management system also, it takes the input. Inverter has lot of current running through them, particularly if you are driving quickly. So they are also linked to the battery cooling system, allowing coolant to keep the temperature manageable. Finally, electric vehicle inverter can convert the direct during the braking. One more thing. So during the regenerative braking, what happens, that you are putting the brake, right, and your motor becomes the generator, right? So your motor is giving the AC current, then it will convert to DC to give back to the battery pack. Then only your battery pack can accept this current, right? So this is the also work of inverter only, which can subsequently utilize to recharge the battery. That is called the regenerative braking. If you have any doubt, please comment on the comment box, so I will try to give the answer. We are going in series only. You can see we have started from charging port, then OBC, then battery pack, then inverter. So this is the Tesla's inverter. It looks like this. There are many design or packaging way of doing the construction of this particular inverter. We will see. If you see, this is also Tesla's inverter. This is your motor and this is your inverter. So this is the main brain of your vehicle. Then we I have already told you till here we went to the battery, then it will come to your inverter, then it will go to your motor. So sometimes this I as already told you, like inverter comes in this shape also, sometimes they are come as separate also, like this. So motor will be separate, this will be separate, however they will be connected through the wires, but they comes in the rectangular form also. And as I shown you like this also. So Tesla is making this type of inverter also, and this type of inverters also. Some of the OEMs making this type of rectangular boxes like this inverter controller. Now coming to the electric traction motor. So electric traction motor, as you know, the main function of this to run the vehicle. So this is using the power from battery pack, and this motor drives the vehicle wheels. Some vehicles use motor generator that perform the both drive and regeneration function. So okay, so this particular option depends only on the motor. Regenerative braking depends on the motor, whether your motor is supporting both the function as a generator or alternator. If you have this type of motor, then it will support and it will be useful for the regenerative braking. So motor converts your electric energy into mechanical energy and drives the wheels and propel the car. Motor vary hugely. Some run off DC current, some of alternating currents. So as I told you, there are many types of motors. Some run off with a direct DC current and some run off with the alternating current, but most of the passenger car are using the AC motors. So most of the common electric vehicle converters are AC due to them being a more efficient, and a more motor is effectively large electromagnet that turns due to attraction and repulsion of north and south pole. Okay, repulsion of the magnet within. Electric motor are very size in the power. So if I take one example, in average classic car, that would be 120 horsepower, where Tesla large drive unit can generate upward 500 horsepower if required also. So generally if you see one particular vehicle, that it would be around 120, but as I given you the example of Tesla, so Tesla can generate till 500 horsepower if it is required through the inverter which we have used. Motor turns the transmission or gearbox. So here we are we are using only single gear type, because we do not have we are not required here. So we'll see, which can be either original one or single speed unit is specifically designed for electric power. Using a original gearbox lower the cost of converting the classic car to electric power as the little fabrication of new drive. So you do not use the drivetrain which you are using the in ICE engine, because here your inverter is doing everything and you do not need any gear like one two three four. Okay, and your reversing also is happening very easily here, because you have to just change the phase. Okay, so if you are changing the phase, then it will reverse, the motor direction will reverse. Like suppose if your motor is rotating clockwise, and if you rotate your change the phase, then your motor direction will be in opposite. So reverse is very easy in this also. However, using the Tesla drive unit that has mounted across the axle, therefore needs custom half shaft differential and drivetrain. We will see some of the OEM are using the differentials also, but that would not be that much complex which we are using in the normal combustion internal combustion unit. So this would be like this. You are your unit, and this is the your gearbox or single transmission box. We will see. Sorry, I told you. So in some of the vehicle, the inverter will look like this. Your electric traction motor, if I take the example of e-tron, od e-tron, so here you will be having the gearbox with plant gear, but it will be an integrated part. Okay, so it won't be like a separate unit and a lot of big unit. Then this is your power control unit, nothing but the inverter, as I told you. Then you have the coolant connection, so the coolant will be flown in the motor, so that it will be thermal cooling will be maintained. Then this is housing. Then you have, this is the stator, this is your rotator, this is the rotor, and then bearing plate. So this is the structure of the od. Different OEM can be used different type of things. So as I told you, see here, if you see the inverter and controller, they are using in the rectangular form, but if you see the Tesla is using as a integrated form and one single PCB. Then you might be having the different type of traction motor. We will uh, discuss this particular thing in detail. So brushed DC, BLDC, brushless DC, PMSM, then induction, then SRM, then SYRM, then AFR. So we will discuss all these motors. So but if I say in one line, so PMSM is the motor which is mostly used, permanent magnet. So this is the motor which is mostly used, and this is the AC motor. Then we will see the DC-DC converter. So we will see other parts in the next video, but we will cover this particular electric vehicle in complete in the chapter form, as I have shown you the contents. So we will cover all those topics, but as of now I am stopping. I will just show you what are the other points we are also going to cover. That DC-DC converter we will cover. Then auxiliary battery, what is the function of this auxiliary battery and how it is giving the power. Then thermal cooling system, what is the thermal cooling system of this. Then it looks like this, you will be having the pump and other stuff. This is your battery, this is your pump, which is here you have the coolant which is going inside the battery. Then you have the transmission, what type of transmission we have. Then what is the specification. So most of the things we have discussed theoretically. In coming video we will discuss practical one practical example we will take of electric vehicle, and we will start with the practical rating. Then how electric vehicle works. So as I have already told you, so motor controller inverter is the brain of the operation. Receive the input, calculate how much power is needed from the battery pack. When you are propelled by the electric motor, when you are putting your foot on accelerator, then this is the thing which happens. Inverter then sends the amount of electric energy to the motor based on how hard the pedal is pressed. Electric energy is converted to the mechanical energy, that is rotational, by motor using the electromagnet. Output shaft on the motor rotate inside the transmission, and transmission adjusts this rotation into the speed that can be used by rest of the drivetrain. So this is the overall process of how electric vehicle works when you are pressing the pedal, accelerator pedal. We will see in detail. So we will see here that what are the rating, how the cooling pumps works, what is the PDU, what are the contactors, how the contactors are work. This is your battery, this is your onboard charger, why these contactors are given, what is the port box, somewhere it will be port box also. We will see that also. IV smart. So these are the points we are going to discuss in the coming chapters. So if you like the video, please like, subscribe, and comment and share with your friend, so it will be helpful for others as well. Thank you for your time.